In this video, we are going to speak about connectivity and how to compute the connected components with Gephi, and also to the detection of communities. So we are first recalling the definitions of connectivity, and first in undirected networks or graphs, we say that the network is connected if all the nodes are accessible among them. This means that we can start from one node and arrive to any other node through just a single edge or with a sequence of them with a path. But in many cases what we will have is that the network is not connected, but there are subsets of nodes which are connected. To each one of these subsets we call them connected components or connected subsets of the network. These definitions were given by undirected graphs, but we can also set similar definitions for directed networks or directed graphs. We recall that there were two definitions. On the one hand, if for finding the paths, we are respecting the direction of the arcs. This was strong connectivity, but what we can do is to omit the direction of the arcs and to consider this as a undirected network, and this definition is weak connectivity. In both cases, the connected components can be computed with Gephi, and Gephi will show us how many nodes we have in each connected component, and to see particularly each node to which connected component belongs. What we will do is to see the data lab and to see each node in its row to which connected component belongs. So as an example, if we want to compute with Gephi, what we do is we choose if the network is directed or not. In our case, the Zachary's Karate Club network was non-directed, and the results are shown here to the right. So what we have is that the network was connected with one single connected component and with 34 nodes. So on the x-axis, what we have is the number of nodes of the connected component, and the number of connected components with this number of nodes are represented in the y-axis. Here we consider it as an undirected network. So in this case, what we have is that this agrees in fact with the notion of weak connectivity that we have for directed networks, and this is what is indicated there. So apart of considering connectivity, what we can study are the communities, and in communities are subsets of a network which are more connected among them and less connected to other nodes or other subsets. To each one of these sets of nodes, subsets of nodes, we call them communities, and the thing is that we will introduce a measure in order to see at to which point we consider that the nodes are connected among them respect to the others. So there are several algorithms for computing this. The most relevant one is the Luvan algorithm, and this is based in the computation of modularity, which is the measure that indicates to which point nodes are more connected among them than respect to the others. So just we will give a shot about how this algorithm works, and the thing is that it works iteratively, reducing the number of communities. So for doing this, we use a parameter which is the resolution that we initialize the method with this, and it indicates at which point we want to reduce the number of communities. So in each iteration of the process, the algorithm works like this. First, we start with each node associated to a community. At the beginning, we have as many communities as nodes, and later we are testing if associating the node to a community, to another community of some of their adjacent nodes, we can reduce the local clustering, right? So if so, what we are doing is to compute a new network, which is a condensation network, and all the nodes of a community, they are considered as a unique node. And as long as two nodes are connected in different communities, what we have is that in the condensed network, we have that the nodes representing each one of these communities are still connected. So for computing this in Gephi, what we do is we initialize the weights randomly. We use weights, we can indicate, and we indicate the resolution. So if the number of the resolution is small, we have more communities. with a smaller number of nodes or lower number of nodes. If the resolution is higher than 1, what we do is we reduce the number of communities with more nodes in each community. So here the result, once you run the algorithm, here we have several parameters. We have the modularity, right? And the number of communities started enumerated from 0, 1 to 3 here, the 4 communities that we have. And as in the previous case, we have in the y-axis the size of each one of the communities, right? So here in this case, what we have is that the first community, community 0 has 12 nodes, community 1 has 5, community 2 4 nodes, and community 3 has 13 nodes. To see the number, to see each node to which community belongs, as we have said before, we have to go to the data lab table. So here, check that, for instance, if we change the resolution and we put it as 3, what we have is we have less number of communities, and in this case, we can see that we have only 2 communities, 0 and 1, right? And in this case, what we have also is the modularity has been reduced, right? So here what we can do is we can use the modularity class in order to paint the graph. So here in the left part in appearance, what we have chosen is a modularity class. We have to paint the nodes by a partition, right? And what we have is this this degree of this different colors. So the white we have only 2 communities, as we have seen before. So what we have is that the white color will be for one community and the dark green color will be for the other community, right? So in this case, what we can see is we can make it wider, right? We can see what is the arrangement, and we can see clearly that nodes 1 and 34 and in different communities that were associated to the relevant nodes, relevant roles of the Zachary's Karate Club network. And to see a better picture, we will see in the end that there are several arrangements that can help us to visualize this. One of the options in the distribution is to use force atlas 2, and with these parameters of scaling 100 and gravity 1, so we can have a picture similar to this, right? Where we have that the nodes are separated clearly into communities. The thing is that here the gravity indicates that nodes that are in the same community will attract more respect to themselves. And with the scaling, what we are doing is to spreading in that region, and with this we can get this output. We will see in the future videos, next videos, how to deal with distributions and to improve the representation of the network.